Hi, my name is Becky Bundy, and I'm a science education specialist with the Sanford Underground Research Facility through Black Hills State University, and this is my assistant today.
Hi, my name's Dylan.
We'd like to welcome all future neutrino scientists and matter mystery investigators who are joining us today. Now, if you happen to have a balloon ready, I'd suggest you go ahead and blow it up, but note that these activities work best when it's dry, when the air is cool. The winter is really the best. And some of the things that caused us to do these investigations came about this winter. But things are working for us well right now. But if you live in a hot, humid place, you might want to bookmark the recording of this presentation, which will be available later. And on a cool, dry day, try it again. So let's see, this would also be a good point before I blow up the balloon to say that anytime throughout our presentation, if you have things that you notice or things that you wonder, please use the chat function. And we hope you'll be following along and participating and investigating with us today. But if you'd like to begin by just telling us who you are and where you're from, we'd love to know. And I'm going to start by blowing up our first balloon.
And we present to you Shockingly Static Science.
Also say, if you don't have a balloon with you today, we're going to show you how you can do some of these things without a balloon. But we thought we'd start with a balloon because, well, it all started for us with a balloon this winter. And Ellen, would you maybe begin blowing or charging that up for me on your sweater? Came about this winter when we were wearing wool sweaters. So you don't have to put yours on. Actually, we need one that's not on, Owen. Please. Okay, so I'm pretending it's winter, which really wasn't all that long ago here in Lee. And Owen is going to charge up this balloon for us.
Smells weird.
Actually, I think I'll just do this one.
I
need
felt
more.
a tingle.
You felt a tingle?
Yeah.
All right, well, that's good. What do you notice? Do you feel anything?
I feel tingling. I also feel tingling from the balloon I'm charging.
Huh. Let's see.
It just stopped me.
You did. I wonder. Oh, hold on a second. You have a new hat. How is yours going, Owen?
I'm still charging it up.
Oh, that was shocking.
Yeah.
Here, would you like this one?
Yeah.
Okay, so let's see. So, Owen, what have you noticed so far?
That it attracts my hair.
It attracts his hair. This balloon. What could you feel?
Well, I could feel a little tingle, and while you're experimenting, you'll probably feel that when you're putting it. Your partner will probably feel it when you're putting it near your partner's hair. You can also do it on yourself.
I can also feel something on the back of my arm. Oh, in my hand, the back of my hand. I'm not sure what I feel. It's very interesting, but I do notice that there are some hairs on the back of my hand and the back of my arm. Do you think? Oh, I feel a tingle. Do you think the hairs on the back of my arm could be attracted to the balloon like yours were?
Yeah, probably.
Wow, it's like I can detect a charge. Interesting. So it turns out when we started investigating that this is all due to static electricity.
Excuse me?
Oh, uh-oh. Bad hair day coming. So, static electricity. Oh my gosh, it stuck to me. Static means stationary, not moving, staying in place. So,
Hi.
staying in place. And electricity is all about electrons. So, electrons that are staying in place. Electrons, I should probably tell you a little bit about electrons. They are super special. They are an important part of all the matter in the entire universe. So matter in our bodies, in tables, in our houses, everything is made of atoms, and atoms usually have electrons. And electrons, you can see here, we use the symbol E for electron and a little negative sign because electrons are negatively charged. And it turns out, assistant, could you get me a balloon, please?
Yes.
It turns out that when we rub balloons with wool sweaters or our hair, or you might not want to try this at home, maybe the fur on a pet, they all take and give electrons to balloons when we rub them on them. So we can charge it with our hair, we can charge it with the wool, and I'm not going to do that to my cat. She would probably pop my balloon. So sometimes when we rub objects on other objects, electrons are transferred. So I want you to imagine that this balloon is now negatively charged. And our bodies can feel that with the tingles of our hair, on the back of our arm, on our head. But I wonder what else we can do. I wonder how negatively charged objects might interact with each other. So let's see. Oh, assistant, could you hold this for a second?
Yeah.
And actually, would you maybe carefully, without popping it, see if you could give it a nice negative charge with that sweater, please? And I'm going to
Attach a balloon.
ask our viewers to make a prediction. So what we are going to set up is 2 negatively charged balloons. One will be hanging from the string that we have set up behind us. Then we'll charge a second balloon with the same sweater, so that balloon should get the same charge. And this is a little hand. I don't have the best drawing skills. And we're going to bring this charged balloon close to this one and see what happens. But first, I'd like you to make a prediction. And we'll set it up while you're thinking. And it's hot. Not winter anymore. Okay. Is that good in charge?
Yep.
Can I feel it? Oh, yeah. All right. I'm going to give it just a few more rubs just to make sure. Let's see. Which other balloon should we use? Which one's going to work best?
You might want to use this one. Come back here.
All right, let's have a seat here. Okay, so we have one negatively charged balloon on the wall behind us. And our second negatively charged balloon. And if we get them good and charged, see what happens. I notice we need to raise that up a little bit for this one.
That's what we need.
I noticed that. And I wondered, how could I fix that? Okay, are you ready, assistant? I want you to
Yes.
look closely and tell me what you notice. Okay, here's our hanging negatively charged balloon. I'm going to bring this negatively charged balloon close to it. Hey, where'd it go? Should I do that one more time? This seems really strange.
Yes.
Huh. Okay. Oh, and what did you notice?
I noticed that when this was near the balloon, it went up and out, and well, sort of like this balloon was chasing the other balloon, and the balloon is still up there.
So it was chasing it, yeah, and it's still up there. Wow. Wonder what else did we notice? I noticed that there is a very strong charge, and I could really feel the charges on the hairs on my arm it's like they were standing up, and that kind of tingled. So what do negative charges do to other negative charges? Do they say, whatever? Or do they want to come together? Or do they like to get away from each other?
They don't like each other. They're mean to each other.
Electrons don't like other electrons. It's true. So when you bring a negatively charged object towards another negatively charged object, well, it's too far away from me right now. The electrons try to get away. So we say they repel. So we have another prediction for you to make. This time, we're going to bring this down because we're not going to use the balloon on the wall quite so much anymore. We're going to use our charged balloon and an uncharged object. And in this case, we're going to use an aluminum can that's dry and empty. So I'd like you to predict this time, when we bring the balloon close to the uncharged aluminum can, what do you think will happen? What do you believe you will see?
Let's charge this thing up.
Okay. Let's see. Let me move some things over. We'll get some space as well. Okay. Are we ready? I'm going to go ahead and move this to the side so that you can see. This is the most fun part. It's charging objects.
I love. Let's hope we get to the tug of war.
Oh, don't tell them too much yet. Okay, so negatively charged balloon. Remember not to touch the table. Uncharged aluminum can. Whoa, we really got going that time. Whoa, maybe we should show that again. Let's make sure that went too fast.
Yeah.
We need to show that one more time. Okay, we have our aluminum can. Come to me. No, don't do that way. Come this way. No, what are you doing? No, don't go over there. Come over here. Come on, follow me, follow me. Follow me. Huh. So what do you notice? What did you notice, Owen?
Well, I noticed that when this balloon got close to there, it went towards the balloon.
It went towards the balloon this time. So negatively charged balloon tried to get away from a negatively charged balloon, but the uncharged aluminum can actually tried to come towards the negative balloon.
Even though it wasn't a positive charge.
Yeah. Wow. If you're familiar with magnets, you might know that magnets have a negative and a positive, and the negatives repel the negatives, but the negative attracts the positive. And that happens with static electricity too. But I think the most cool thing is that charged objects like this negatively charged balloon can attract uncharged objects even, like this aluminum can. Let's see. What about, there's one more thing that we want to show you before we ask you to just do some experimenting and discover some things of your own. What can we charge that's not a balloon?
Well,
And maybe we should use this as our charge detector.
we can use a spoon.
Ooh.
Back, get back.
Oh. Oop, I got my sweater here too. We each have our own wool sweater. And I have a plastic baseball bat. And Owen has a plastic spoon. I think I'm ready. I'm going to go ahead and see if my plastic bat. Woo! Woo! I had to squash it so it didn't get away. Whoa, I could really feel my hair there. Whoa, this one's really charged. Whoa. Whoa. All right, so what have you got, Owen?
I'm still charging.
Oh, plastic spoon, that's right. Huh. I wonder if rubbing things with different materials makes a difference.
Come on, follow me. Come on.
What do you think? Should we ask our viewers to help us discover more exciting things?
First, though, I challenge you to a tug of war with our magic static wands.
It's a straw, a plastic straw. All right, challenge accepted. We're gonna tug of war.
Gotta tug it up really.
My electrostatic force is greater than yours.
No, mine is greater. Last time we played, you couldn't even do it at all.
What? I'll crush you.
I